Hello and welcome to lesson number 6 in unit number 1 here. And today we're talking about position time graphs. So what is the learning goal? I want you to be able to explain and create the motion of an object based on a given position time graph and determine the associated values from the given graphs. So we'll start off with something you should be familiar with, coming from the grade 9 course, grade 9 math course, VQAO, and that's describing the motion of an object given a position time graph. So we call this a PT graph, all right, and that's because we have time on the x-axis and position on the y-axis. So you will have done a calculator task a little bit earlier on here, practicing or figuring out the different types of motions. So hopefully by this time we can just kind of go through these. Excuse me. Anytime there is a kink or a break in the graph, there's been a different motion brought forth. So here there is 1, 2, 3, 4 regions to describe. Okay. So here I'm giving you an example of what I would expect on an assessment or on a test, just so you have that in mind. So for stage 1, it is a negative slope, which means that you are, and it's a line, so you are moving backwards with a constant velocity. All right. So what I'm expecting, or what I want to see, is I want to see a direction, and I want to see a descriptor on the motion. All right. Stage 2 is a horizontal line. It means your position has not changed. You're still negative 2 meters from your starting point. So this one is simply standing still. Stage 3 is another line, and it goes up to this curve. So what's happening? We are moving forward with a constant velocity. So anytime it's a line, velocity, anytime it's a line on a position time graph, it's going to be a constant velocity. And the fourth one that you've done through the investigation, there's a curve. So we are still moving forward. And what's happening, let's see if I can draw this properly. So if I draw a line, see my line here, we see that the line as it, oops, can I hold on to it? As it moves on your curve here, what's happening to that line? It's flattening out to become a horizontal line at the end there. If it's going to be a horizontal line, that means you are coming to a stop. So you're moving forward and you are slowing to a stop. All right. So it's important to know you're being able to describe each stage. This is what I would expect on an assessment. So summary of the position time graphs in motion. This hopefully you got out of the activity. So if you have a horizontal line, you're standing still. All right. If you have a negative slope, you're backing up with constant speed. If it's a positive slope, you're moving forward with constant speed. If you have, and here's where it gets a little bit tricky, we just talked about this curve. So forward, but slowing down. All right, and that curve, again, it's becoming a horizontal line, so that means you're coming to a stop, or you're standing still. And the other one then, that looks like this. So now, here's where you're standing still, and now you've changed. So again, you're moving forward, but speeding up. All right. You've gone from a stop, and now you're moving forward, so that means that you are changing your speed. You're speeding up. The other ones, let's see if I can get them right first try. This one here. Again, the end result is a flat line, so you're backing up. But we are slowing down, coming to a stop. And the other curve looks like that. Started with a flat line, so now we're backing up. But we're also speeding up as well. So we're going faster and faster backwards. So hopefully you are comfortable with those from that investigation that you went through. So what is the relationship between PT, VT, and AT graphs? So what I want to do is I want to take a position time graph like I have here in the first one, and I want to create a velocity time graph. So it tells me how fast was I moving in that time interval. Okay, so let's do the easy ones first, and then you start to see the pattern. In this region right here, and this region right here, how would you describe your motion? It's a flat line. We just talked about that. We are standing still. If you are standing still, what is your velocity? Well, the resulting velocity is 0. So from 7 to 10 seconds, my velocity has to be 0. So that means I'm going to color, I'm going to exaggerate it so you can see, but there is a line from 7 to 10 because I'm not moving. Similarly, in this region, you're also standing still. So that means from 2 to 5 seconds is also sitting on this line. You're not moving, velocity is 0. Okay, so you can exaggerate it. What do we know about a horizontal line? Well, a horizontal line slope is equal to 0. Remember, horizontal line, if you're on a toboggan, it's no fun, so it's 0 fun, 0 slope. So that means that our slope is equal to our velocity, which we know from an earlier lesson. So that means we need to find the slope of our other two lines. Slope is rise over run, so I'm writing all over the board here. Rise over run. So the first region, I'll use my magic pen to start. The slope of this line right here is 1, 2, 3 high and a run of 2. So that means that the slope then is 1.5. So I'll do it down here. So I'll call it slope 1, 3 over 2, which is 1.5. So I go over here and I just draw in a horizontal line. I am going 1.5 meters per second from 0 to 2 seconds. Okay? It's just the slope. That's all I've done. All right? The slope of the other line. There it is right there. 1, 2, 3, 4, 5, 6, 7 high and 1, 2 long. So if I want to do the slope of the third segment here, rise over run. Now I know it goes down, so it's -7, runs 2, so -3.5. So for those 2 seconds, I am at -3.5 meters per second. All right, and there we go. That is your velocity time graph from a position time graph. Now, if we were to find the acceleration, because the next page, oops, we're just looking at VT, perfect. If you take a quick look though, what is your acceleration in each of these cases? Because you have uniform velocity, all right, that means that our acceleration is 0 in each stage. Acceleration is 0 in each stage. So I always like these types of graphs because I don't have to calculate acceleration ever. All right. So for that position time graph, acceleration is 0 everywhere because our VT, okay, has horizontal lines in it. So the next example, determine, we want to find the VT graph from the given PT graph. That's just what we just did. So the first thing I would do, excuse me, is identify any places where I'm not moving, because those are the easy ones. Standing still, standing still. If I'm standing still, I have no velocity. So for the first 3 seconds, I have no velocity. So again, you can exaggerate that line. And for 6 to 10 seconds, I'm not moving. Also 0 velocity. There we have it. Okay. Now the other 2 stages, we're going to have to find the slope. So from 3 to 4 seconds, because that's where a break occurs, I have 1 second of run. 1, 2, 3, 4, 5 seconds of rise. So let's call that segment 2. So it's segment 1, 2, 3, and 4. So what is the slope of segment 2? Rise over run. 5 over 1. So it's a slope of 5, and it would be meters per second or whatever we're working with. So from 3 to 4, it's going to be a value of 5. So it's way up here. So put a horizontal line in there. The next one, segment 3, rise over run. Here's the triangle, up 2, run of 2, 2 over 2, 1 meter per second. So that means that I've dropped for those 2 seconds just to a velocity of 1. That's all it is to it. You're done. No other expectation with this section. So the summary from PT to VT, step 1, find slope of each line segment on PT graph. Step 2, plot the slope on the VT graph. All right, that's it. That's all that's expected when you go from a PT to a VT. So right now, for us to do this visually, there are 3 types of graph. There's PT, VT to AT. So if I was to go from a position time to a VT graph, you would find slope. Okay, so that's what we know to this point. Now, what is the relationship going the other direction? What is the relationship going the other direction? So let's look at the other side here for a second. We're going to look at, let's analyze the first segment here. Okay, so in the first 2 seconds, you traveled at 2 meters per second. So for segment 1, this is section 1, we know that we know a velocity was 2 meters per second, and we know a time, it's 2 meters per second, or 2 seconds, sorry. Knowing that information from an earlier lesson, we know D equals VT. So that means that if I put 2 times 2 in, we traveled 4 meters in the first 2 seconds. Excuse me. So that first one, if I start at 0 meters, after 2 seconds, I have traveled a total of 4 meters. Okay? Now, is there a quicker way to do it? For sure. Because if you notice, this is your time right here. The height of this is your velocity. If you take V times T, because that's what we did down here, V times T, this is just area under line. So all we got to do is calculate the little boxes, area of each little box. So this one was plus 4 for an area. This one here, 2 seconds times 1, so it's plus 2, and so on and so forth. So I'll finish this up in the next video, and then you can try some of the homework.